Hi everyone, we are moving on from linear functions, we're moving on to just general functions. So, define a function. A function f from set A to set B is a relation that assigns to each element x in set A exactly one element y in set B. So x can only go to one value in set B. Now the set A is the domain or set of inputs of the function, and the set B contains the range or the set of outputs. So first of all, and we'll look at some examples with that, evaluating a function, if we let f of x equal 10 minus 3x squared, we can find each function value. So f of 2, we replace the x here with 2. So I go 10 minus 3 times 2 squared, which is 10 minus 3 times 4, which is 10 minus 12, which is negative 2. F of 2 equals negative 2. If you put 2 into this function, you get negative 2 out of the function. The input's 2, the output is negative 2. Negative 4, so 10 minus 3, those parentheses don't belong there. 10 minus 3 times negative 4 squared. That's 10 minus 3 times 16, which is 10 minus 48, which is negative 38, which is f of negative 4. Now sometimes we can just put an expression in for the function. So f of x minus 1. I am taking the x out of here and replacing it with x minus 1. The 3 stays though. 10 minus 3 times x minus 1 squared. So that is 10 minus 3 times x squared minus 2x plus 1 if I expand x minus 1 squared. And then if I distribute, I've got 10 minus 3x squared plus 6x minus 3. And let's just write it in an order from descending order of exponents. Let's write the negative 3x squared first, plus 6x second, and then the 10 and the minus 3 is plus 7. So if I plug x minus 1 into this function, the output that comes out is negative 3x squared plus 6x plus 7. Alright, a little bit about piecewise functions. The piecewise function kind of depends, which function you use depends on the domain, the value of x that you're trying to find for it. So if f of x equals x squared plus 1, if your value of x is less than negative 2, then you use this piece of the function. If your value is negative 2 or less than 0, up to less than 0, you use this piece of the function. If it's greater than or equal to 0, you use this piece. So let's just look at these 5 and make sure we choose the right piece to use. Okay, so f of negative 4, negative 4 falls in this category. So we're going to use this first one. So we're going to take negative 4 squared plus 1, which is 16 plus 1, which is 17. F of negative 2. Negative 2, this is for less than negative 2. This is greater than or equal to negative 2. So or equal to part negative 2 means we're going to use the second piece here. And we're going to take negative 2 minus 1, which is negative 3. Now f of negative 1 falls between negative 2 and 0, so we're going to use this piece again. So that is negative 1 minus 1, which is negative 2. F of negative 1 is negative 2. F of 0, x is less than 0. Well, 0 is not less than 0, but 0 is greater than or equal to 0. So we're going to use this third function and take 1 minus 0 squared, which is 1 minus 0, which is 1. So f of 0 is 1. F of 1 is greater than or equal to 0. I'm going to use this third piece and take 1 minus 1 squared, which is 1 minus 1, which is 0. So piecewise functions is just picking out the right piece of the function to use based on these domains over here. All right, next part of functions that we're studying is when does f of x equal g of x? So I have f of x here equaling x squared plus 6x minus 24, g of x equaling 4x minus x squared. Find the values of x for which f of x is equal to g of x. Well, if f of x equals g of x, then f of x, which is x squared plus 6x minus 24, will equal g of x, which is 4x minus x squared. So it's just a case of solving this. Let's add x squared to both sides. Let's also subtract 4x from both sides while we're at it. And we're dealing with 2x squared plus 2x minus 24 equals 0. I am going to factor out a 2 right now. X squared plus x minus 12 equals 0. If I divide through by 2, I have a simplified equation, x squared plus x minus 12 equals 0. And that factors pretty nicely, I think, because 4 times 3 is 12. And I need a positive, so I'm going to make the x plus 4 and the x minus 3. So x plus 4 equals 0, which means x is negative 4. X minus 3 equals 0, which means x equals 3. Okay, I think we found our two values. If I plug in, just checking real quick, negative 4 squared is 16. 6 times negative 24, or negative 4 is negative 24. 16 and negative 24 make negative 8. Negative 8 minus 24 is negative 32. Now this is 4 times negative 4, which is negative 16, minus negative 4 squared, which is positive 16. 16 times minus 16 is negative 32. And if I check for 3, that's 9. Plus 18 is 27. 27 minus 4 is 3. If I check this, 4 times 3 is 12. Minus 3 times 3 is 9. 12 minus 9 is 3 as well. So we got two values here that make f of x equal g of x. Alright, next part. When does f of x equal 0? And I have find all the real values for which f of x equals 0. Let's set what f of x is equal to, x squared minus 16 equal to 0. That's x plus 4 times x minus 4 equals 0. X plus 4 equals 0, or x minus 4 equals 0. So x equaling negative 4, or x equaling positive 4. Those are the two values. Negative 4 squared is 16. 16 minus 16 is 0. Positive 4 squared is 16. 16 minus 16 is 0. So if you get a question like this, just set it equal to 0 and solve. Alright. Now, next thing on functions is the domains. What can x be, or what is x? In this first part, the domain are the x values. I see a negative 2, I see a negative 1, I see a 0, I see a 1, and I see a 2. That is the complete domain of this function. This is defined out very clearly, specifically. This one, it's in the equation form of a function. And we just really have to determine what values we can put in for x. And there's one problem. If we divide by 0, then the function would be undefined. So we want to avoid the value that would make that 0. And that's the denominator. The denominator is 3 minus x. If it equals 0, that's x is 3. So x cannot be 3. So the domain here is all real numbers except 3. And in function notation, we can go from negative infinity all the way up to 3, not including 3. And then we can pick up after that, again, not including 3. This will just exclude 3 and go all the way boundless to the right also. So this is function notation for this domain. This is just saying it in words. All right. Now, part C here, the circumference of a circle. We got the circumference formula. C equals 2 pi r. R is the radius. That is the independent variable. C is the dependent variable. R is what we're interested in. What values can we use for R? Okay, if R is 0, you don't have a circle. So that doesn't make sense. I'm going to say R is greater than 0. Would be the domain that I would choose here. Or if you wanted function notation, you would not include 0. You'd go all the way down to 0 to infinity. All right. And D, h of x is equal to the square root of x minus 16. Now we're talking about, we can define it in complex numbers. We could use I and stuff. But let's just define the domain in terms of real numbers. X minus 16 cannot be negative. It can be 0, but it can't be negative. So x minus 16, what's under the radical, has to be greater than or equal to 0, which means x is greater than or equal to 0. Add 16. X is greater than or equal to 16. And if I were going to write that, I'd put 16 here, and however high you want to go with that. Okay, one last problem. This puts a radical down in the denominator, so it kind of combines B and D. That can't be 0. Can't be 0. Can't be negative. So x plus 7 is just greater than 0. That's different than this. This is greater than or equal to. Greater than 0, because if x is equal to 0, or if x plus 7 is equal to 0, we're dividing by 0, which we can't do. So x, the domain here, x is going to be greater than negative 7. So I'm going to put a curved bracket on negative 7, and then you can go as high as you want past that, and you'll be able to find a value for the function. All right, guys, you take care now.